Hi everyone. This lesson is going to be about activity networks and forward and backward scanning, which is a process we use to determine the completion time of the project. So here is an activity network that's given to us, and we can see here the activities A, B, C, etc. are represented by the edges, and the numbers here are the weightings on these edges. They might represent the time taken to complete each of these activities. It could represent a cost, could represent anything really, but let's just imagine these are times. So notice also these edges have arrows. This is a directed network, and the fact that we start here at this point, activity A has to finish before we can attempt activity D. So this is called a prerequisite or an immediate predecessor of D. Likewise, B is a prerequisite of E, C is a prerequisite of F. Sometimes, like we have here with activity G, sometimes there are two things that have to be completed. Both D and E must be completed as immediate predecessors before we can attempt G. Now, how do we go about doing a forward scan? Well, there's a number of ways. We could we could redraw the thing, and when we redraw the network, instead of vertices, we put circles. So I would have a circle here at the start. And then we would have activity A, which takes 7 units of time, say 7 minutes. That's a vertex. Then there's another vertex here. This is activity B, which is 2, and then there's another vertex down here somewhere. And this is C, which is 6. Then what did we do? We had a vertex over there. There were two edges there. That one is D, which is 8. That one is E, which is 7. Then there's a vertex there. That's F, which is 9. This is G, which is 5. Finally, we have activity H, which is 3, and this is the finish. Now, we divide these circles. I'm just going to increase the size of that one down the bottom there. Just a little bit on the small side for my liking. Now we divide these circles into two parts. Some people divide them with a vertical line, some people divide them with a horizontal line. It really doesn't matter. To be consistent with the textbook that we're following, I'm going to use horizontal lines. Now, I start my forward scan at the beginning. That's pretty obvious. And at the beginning, the time elapsed for the job is 0. As I perform activity A, this takes 7 minutes, say that's minutes, then I'd have a 7 here. As I perform activity B, that would be 2 minutes elapsed by the time we get to there, and activity C would be 6 minutes elapsed. That's all pretty good. Now we get to this vertex over here. I have to go from 7 plus 8, it could be 15, or I have 2 plus 7, it could be 9. Now which one of these do I pick? Well, remember I said that both D and E are immediate prerequisites of G. We cannot begin G until we have finished both D and E. Obviously it's going to take longer to complete D. D was 7 plus 8 is 15. I cannot begin G until 15 minutes has elapsed. Minimum. That's the earliest I could start. Now I know that B and E would have been finished in 9 minutes, but I can't start this one until D is finished, and the earliest that could happen is after 15. So when faced with a choice, when there are two edges leading towards a vertex, 2 or more, pick the largest value. Now the same process will happen here. I have 6 plus 9 would be 15, or 15 plus 5 would be 20. We will pick the largest value. Then 20 plus 3 is 23. These times that I've written here in the tops of these are from a forward scan, and these represent the earliest starting times. for each of these jobs. So I'll highlight that yellow to make that clear. And the forward scan, remember, as we're moving forward, if there's 2 or more edges leading to a vertex, we choose the largest value. Now we're going to do a backward scan. As the name suggests, we start at the finish and we work backwards. Now we know that there's 23 minutes to that point. Instead of adding, we subtract. So 23 subtract 3 will give us 20 at this point. There's only one edge leading back here. So 20 subtract 9 is 11. Now there are multiple edges to get to that point. I won't do that yet. There's only one edge leading back here. 20 subtract 5 is 15. That's okay. There's only a single edge leading back here. 15 take 7 is 8. I won't do that one yet. There's multiple edges. 15, there's only a single edge coming to here. So 15 take 8 is 7. Now I'm at the point where I can fill in the numbers at the start. And there are multiple edges leading back to the start. So I'll have to consider all of the possibilities. I have, from the top here, I have 7 take 7, so it could be a 0. I have 8 take 2, it could be a 6. I have 11 take 6, it could be a 5. Now, because we're working backwards, remember in a forward scan we picked the largest value? It's the opposite. When we're working backwards, we pick the smallest of the choices. Now, here are 3 different choices. The smallest is 0, so I'm going to choose 0 and write that in the bottom half of this vertex. Let me highlight those numbers. There they are. And those represent the latest starting time. There we have it. That's your forward scan and your backward scan completed. Remember to start from the beginning and move forwards for your forward scan, choosing the largest of the values if there are multiple choice, more than one. When moving backwards, we subtract. We go from the finish and we subtract, and if there are more than one choice available, we choose the smallest one on the backward scan. All right, that's enough for this one. Thanks for watching.